First of all, I would like to thank very much for this invitation to deliver this keynote. It's really a personal pleasure, and you will hear that also the note of my talk today will be less, it is going to be scientific, but also a bit personal, since I worked closely with Sven, and we have a lot of hard nights and hard hours behind us together in the Intergovernmental Panel on Climate Change. And during this work, I got quite familiar with the whole energy revolution concept and work, which I respected and admired a lot. And so it's a special privilege for me to be able to introduce its advanced energy revolution study in Hungary today. So, as I said, I will be a bit more personal today. First, I'll say a couple of words about why talk revolution. It's a big word. Why do we use that? Why I think it is very important that we have this perhaps sensational title, but it is we can settle for nothing less. Then I'll like to say a couple of words why I believe the energy revolution study is so important. Actually, the whole talk is about that. I will also say a couple of words about gossips, rigor, extremes, and the energy revolution. And finally, I'll relate to Hungary, the sustainable energy revolution for Hungary, what follows after the report. The content is very well in the report, but then what follows, what does this mean for Hungary, especially some words about the cost-benefit analysis of coal benefits. So, you know, revolution, it's a big word, we don't like these, and in fact, among ourselves, experts in the energy community, we often debate whether we should use these strong words or not. But in fact, a lot of us do believe that we should. I put here the picture of the Global Energy Assessment, which is going to be published in a couple of months. That's a very similar assessment to the assessment reports of the Intergovernmental Panel on Climate Change. Simply, it recognizes that energy has many other problems than just climate change, and we need to solve several of these challenges together. So beyond climate change, there are significant energy security problems, environmental problems, health issues, energy poverty and poverty issues, energy access problems, and so on. And we need to tackle all of these. The assessment is similar to the IPCC, that it gathers a lot of leading experts from around the world in order to try to say to the world's policymakers what's important, how can we solve it. And my point is that this community, after about 5 years of work, of several hundreds of experts from all around the world, all continents and many, many countries, basically will also have, we have already concluded, but the book will only be out in a few months. It concludes that there is nothing less than a revolution that we have to go through in order to solve these problems. At the same time, it also concludes what the Energy Revolution study, it confirms the findings of the Energy Revolution study, is that it's possible. It is a transformational change we need, but it is possible. We can do it. In fact, there is not one way we can do it, but there are hundreds of ways we can do it. And the good news is that we are going to be even better off. And this is very much resonating from the findings of the Energy Revolution study, both for Hungary and internationally general. However, it is very important to distinguish and understand that we do need a transformational change, not only in the energy sectors, but in the whole economy. And unfortunately, we understand more and more is that small steps won't take us there. This is where suddenly small is not necessarily beautiful. Of course, I'm thinking of a particular application, but incrementalism will not get us there. We have to use the logic of the energy revolution concept and scenario. Where do we need to get and how we can get there? Instead of, yes, this is business as usual, let's tweak it a little bit this way and this way, and then we will see that we cannot change our thinking. So let me say then a couple of more words why I believe the Energy Revolution study is so important and unique in its kind. don't worry if you can't read this figure. The point, it is from the special report on renewable energy by the IPCC, on which we work together with Sven. The point is, what it shows is the possible evolution of greenhouse gas emissions. And basically, you see, we can be anywhere from now until the end of the century, from almost zero to a significant multiplication of today's emissions. The different colors mean what we have to do, or which trajectories we have to follow in order to meet different climate goals. And clearly, the energy revolution study would be among one of these green lines. So the solution space is big. This is kind of the climate solution space. There are many, many ways the future can evolve and can unfold, but it is extremely important to look at this area. How can we push the frontiers? How can we, if we really, even if we may not get there, it's also based on the talk of Mr. Philip, it is questionable whether we'd get there, but it's very important to understand whether we could get there and how. And unfortunately, even in the fourth assessment report, we hardly looked at revised any literature on these extreme scenarios. Well, extreme in terms of, but it's the fundamental precondition for us to be able to survive, basically, in a reasonable life quality in the longer term. Especially, oops, what did I do? Okay. Especially when we started the renewable energy report of the IPCC, few of us, pushed that we really need to answer the question: can we do this from all renewables? And that was an ambition of the special report. But in the end, what it found, that there is actually fairly little literature and fairly few rigorous studies that assess this question and answer this question in a robust enough way. And among those, very few is actually the Energy Revolution study, which answers, at least relates to this question in the closest way. So that's why important. Now, let me turn to a bit more personal areas. First, when we were requested or approached whether we would host this event and perhaps whether I could write the foreword for this study and whether I would talk, of course, the first reaction was, "Ooh, well, there was this, big scandal about the renewables report. It's just better to perhaps stay away, not being associated with trouble." And I'm sure Sven will never invite me anymore, or Greenpeace, for any more keynotes. But I do want to be honest, and I think it's this is better than if a lot of my empty words or the same slides or same concepts I show anyway, because it's about their report and not about our work. Fortunately, Hungarian media hasn't really picked it up, so you didn't really know this.
It will now.
But then it will know it now, because I'm going to say why it was completely wrong. Basically, the word media was quite full after the publication of at least the blogosphere, but then the media picked it up as well, how the IPCC was mistaken to include a report from Greenpeace, which predicted fairly high share of renewables, and in the end, even there was a Nature editorial on the issue. Now, what I want to say is how it was wrong, and why I feel very comfortable, in fact privileged, that I can be associated with this report. And I was very surprised, and that the arguments didn't get to those. So let me show. I just I don't have time to fight media and so on. I should have, because some of these figures that I'm going to show underline not only the rigor of the whole energy revolution work, which anyway speaks for itself, since the people and the institutions who have done the actual work together with Greenpeace, the DLR, and the other institute, Ecofis, is basically the biggest names in energy efficiency research in Europe. So already the names who are behind the study speak for themselves. But let's look at facts rather than you name and prestige. This is, again, a complicated figure. Don't worry if you don't understand. Just I want to illustrate how the results of the Greenpeace study were not at all the most extreme, even in the IPCC work report that we have reviewed. This is just an example of the so-called one of the regional cost curves figures that I have done for the report which is published. What basically it shows, if it's too complicated, it's basically a supply curve, just like supply curve of bananas, or supply curve, economic supply curve, or toilet seats, whatever, doesn't matter. As a function of cost, you see here the potential, how much we can produce. And there are different scenarios, basically 3 groups of scenarios, the VO, the word energy outlook, and then there are the energy revolution for 2030 and 2050, and also the REMIND scenarios, which are from the Potsdam Institute for Climate Research. So basically those scenarios which are the institution which is now holding the chair, the co-chair of Working Group 3, the mitigation working group of IPCC. And what you see, so these are the two, the yellow and the light blue. This is 2030 and this is 2050. At the same time, these are the 2 REMIND scenarios. So what you see is that the REMIND scenarios are actually much more optimistic about how much renewable energy can be deployed in Europe. And this was true for all the 3 regions I investigated, and also about the cost development of renewable energies. So this is just an illustration, but basically also in the special report of renewable energy, yes, the Energy Revolution study did predict quite a high share, but it was far not the highest. Several other studies predicted that a higher share or higher amount of renewables is possible to be produced. Simply, the Energy Revolution study had the largest energy efficiency potential, and since energy demand came down most, this way the percentage figure came higher than in other studies. Another, and this is confidential, so please don't cite this yet, another area is just, let's look at just the building sector. We are doing for other work, we are reviewing different this is for the 5th assessment report. I'm reviewing the different models, various models which predict, which also project the energy consumption of the building sector globally. And as you see, they are starting from quite diverse because they cover different end uses. But basically the point is that when you look at, this is the energy revolution, the advanced energy revolution, it's really not the most ambitious in terms of trends at all. In fact, it's right along the lines of the World Energy Outlook 2010 for the building sector as well. So it's not at all the most extreme. For the Hungarian study, too, if we look at just the building sector numbers, because there, again, I'm conducting work of comparing different results. This is because they don't cover exactly the same thing. I used percentages, but still the trends are quite important to see. The energy revolution projects about 21% decrease in non-industrial heat demand, whereas our study at 3CHEP, we look at that even an 85% decrease is possible. And the recently completed Energy Club study projects an approximate 42% decrease. So our study, which is at a university, is much more ambitious. You could call this almost advocacy, but at the same time, I should actually be now in Paris at the International Energy Agency presenting this study right now, if there haven't been some Hungarian difficult bureaucracies anyway. This is considered among the top 3 models now in the world of the world building energy use. Okay, so after showing that the energy revolution is not extreme in terms of, it is looking at the extreme climate solutions, but it is not extreme at all in its findings that how far it is possible to go. But it is right there among other studies, solid and rigorous studies. So it really shows that yes, this is possible. It is among those which other studies are also projecting. After this, let me talk, almost this part of the talk should be after you present the study, but I'm afraid I will have to leave. What follows from the findings of the study? And let us say a couple of words about the other benefits of the sustainable energy revolution scenarios. And this is going to be partially based on a report we've done, and you find outside a couple of copies with the European Climate Foundation on the co-benefits of a large-scale energy retrofit, deep energy retrofit build program in Hungary. And we are quantifying, we're using this as an example to quantify that actually not only will you eat the cake and have it, but in fact, you're going to be paid for eating the cake and having it. And in addition, you're going to get a treat for eating the cake and having it and being paid for eating the cake and having it. So let me be a bit more concrete. These are the studies that we are talking about. What we've done is we've looked at, this is roughly the business as usual, how building energy use will develop over the next couple of decades in Hungary. At the same time, if we implement deep retrofits, these are just three different dynamics, we are talking about a potential 85% saving in present building sector energy use. But at the same time, if we implement suboptimal policies or suboptimal efficiencies and not deep retrofits, we are talking about the 45% lock-in risk because you're achieving only a much lower energy savings. But let's look at now the other benefits of this more transformational, the revolutionary, the energy revolution in Hungary, what that would entail in the building sector. First of all, what this shows is that there is no way around it. This will have a huge investment cost implications. And that also is confirmed by the Energy Revolution study. Yes, doing this future does have significant, you will have to look at your purse. Nevertheless, if you look at the benefits, these are the annual investment needs versus the annual energy cost savings. For one of the scenarios we have investigated, one of the deep retrofit scenarios. You see that soon, okay, you will have to wait a couple of years, but soon, even on a national scale, the energy cost savings are going to be significantly larger. So basically, what we estimated that of one of the scenarios we are talking about, not a small amount, 43 billion euros to implement a deep efficiency retrofit scenario for fixing the Hungarian building stock. At the same time, you're talking about over 150 billion euros just in energy cost savings, and I think our energy cost assumptions were significantly more conservative than what I found now in the Energy Revolution study. Also, there are significant energy security benefits. For example, we can save 39% of the current natural gas imports. But in fact, what is the worst for us is January imports, since that's when it happened once in a while, you know, the disputes with Ukraine and Belarus when natural gas stopped arriving to Hungary. Now, with such a deep retrofit scenario, we could save up to 59% of the January average natural gas imports. So just doing this, and basically you made the Hungarian population independent of natural gas, largely because if you, in such a deep retrofit scenario, you basically don't need natural gas for heating the homes. The little need that heat that still needs can be supplied easily by local distributed heating sources. So the energy security benefits are very significant. There are also significant employment benefits, and I'm just showing you one of the figures. For 2020, the employment numbers are not larger for other years. But what I wanted to show you is that, of course, there are many, many studies on employment, but fairly few which are really rigorously investigating all the different macroeconomic effects. And we were very fortunate to be able to work with Professor Ákos Telegdi from the CEU together, who is also directing the labor project at the Hungarian Academy of Sciences. So this we can stand by that this is a very rigorous accounting for all the macroeconomic feedbacks. And what you see, if you put the money into deep retrofits, you are going to achieve a significantly higher employment effect than if you put into many other alternatives. For example, if you put the same money into transport infrastructure developments or other measures. Another issue which is not mentioned at all in the Greenpeace Energy Revolution study, but it's an extremely important consequence of such a scenario that is laid out in the Advanced Energy Revolution picture for Hungary, basically is the elimination of fuel poverty. It is quite a significant problem, and we are very fortunate, but Sergio, I don't think... Sergio, are you here back? No, he's representing 3CHEP in another UN telemeeting, and I hope that he would be back by now. Anyway, he's writing his dissertation, and he has on energy poverty in Hungary with lots of fantastic findings. What this figure shows, for example, how energy poverty has gotten only worse, even just within 3 years of 2005 and 2008. Presently, and I believe actually this is more conservative number than I would say, but it's his number. The number of deaths, excess winter mortality attributable to fuel poverty in Hungary is close to that attributable to motor vehicle accidents in Hungary. So we are talking about a significant number of deaths, not even mentioning the amount of children getting sick because of the problem and not being able to go adequately to school, therefore falling behind in their results and perhaps having much less better jobs later on because they are much more out of school and so on. So, and this I really hope that he would present, because this is his dissertation research. It's very new actually, this is the first time I see it, but it's really a fantastic result. What he's doing is taking this this deep retrofit scenario, which is again in line with the Advanced Energy Revolution of the Greenpeace study, and taking it further. What other benefits are we going to have? Yes, it costs a lot, but let's look at what if we add all the other benefits. And the point is, if you start to add, quantify comfort gains, avoided fuel poverty-related excess winter mortality, if you quantify the savings through additional non-greenhouse gas emissions avoided, the CO2 avoided, the additional energy savings, these are your costs, which I showed earlier, but these are your total benefits. So in fact, you are seeing a cost-benefit analysis which rigorously accounts not even for all the co-benefits, just some of the co-benefits. These studies are very rare, and so this will be a very, very unique study. In fact, you're a fool not to go for the Advanced Energy Revolution scenario, because you're losing a lot of money for not. So it's not that we cannot afford it, but it's rather we cannot afford not affording the Advanced Revolution scenario. So, in conclusion, basically what I pointed out, that we can only solve our energy-related problems through transformative, revolutionary changes in the energy sector and in our economy. And incremental steps, unfortunately, will not get us there. It will be better, it will help, they will help, but it will not get us there. And maximizing renewables is the fundamental pillar of such a future, and I'm sure the previous speaker and also the future speakers will mention that. However, the first step you have to do in order to reach an ambitious renewable scenario is to get your demand down, and that's what the energy revolution scenario is unique about, that it also accounts for a very rigorous energy efficiency improvements. the energy, what I also pointed out and supported with a lot of evidence, that the energy scenarios results are not extreme at all. They are very robust, right among what other studies indicate. So it means this can be done. Nevertheless, in Hungary, this is one of its kind. And it's good news, but it's bad news, because we really need more and more work that gives evidence that yes, you can do it. And this is the way to do it. And it is a unique piece of work, which I'm very happy that so many of you came here to listen to. I use a lot of its results of the previous study, and I will use a lot of its results of this study. Finally, what I've also shown, that if you add the social and economic benefits, quantified, those only that you can quantify, they will be even greater than the direct benefits. So finally, I just want to say that this is why I am doing this. These are my little twins who I have to rush back for, so I have to leave you soon, I'm afraid. But if we want them to, and yours, and your non-born children yet, to live in a Hungary which, doesn't have to take the responsibility for safeguarding the nuclear waste that we have enjoyed the benefits of the nuclear power, I want them to be able to walk on the glaciers that I have hiked on, and I want them to be able to see the Venice and walk on the streets of Venice without being flooded. We have to do all of these. And we have to put all our science and knowledge into finding solutions, exploring the frontiers of the solutions. So thank you very much for your attention, and enjoy your day, and thank you very much for this excellent study.